Hello all. In this presentation, I shall brief you on coupling reactions. Okay, I shall be specifically taking one type of coupling reaction, that is Negishi coupling. Now, before we go into what Negishi coupling is, its mechanism, etc., let us see what is a coupling reaction. A coupling reaction is the one, as the name suggests, which couples two fragments, that is, which brings two fragments together. Now, two organic fragments are brought together to produce another organic compound, and this happens in the presence of a transition metal catalyst. Okay, usually metal catalysts having metals like palladium, copper, nickel, etc., chromium, etc., are used for coupling reactions. Now, depending upon, you have the substrates here, the organometallic compound and the organic halide. The alkyl groups of the organometallic compound and the organic halide are coupled together to form organic compound. Okay, a CC bond is formed. New carbon-carbon bond is formed. Depending upon the organometallic compound you use, the metal, depending upon the type of metal you use in the organometallic compound, and the metal catalyst you use, and the alkyl halide you use, you have got different types of coupling reactions. Okay, you have got Negishi coupling, Hiyama couplings, Suzuki couplings, Still couplings. So you've got different types of coupling reactions, and that type variation is based on the variation in the metal part of the organometallic compound. Basically, this is the main variation involved. Now, let us see the mechanism in general for an a coupling reaction. Now, in general, the coupling reaction involves the following steps, and this is the catalytic loop for the coupling reaction. Now, first step is the oxidative addition, wherein to the organometallic catalyst, to the transition metal catalyst, organic halide is added via oxidative addition. That is, the palladium, which is in zero oxidation state, is changed to +2 oxidation state, and the alkyl group and the halide group is added, or the palladium catalyst is inserted into the alkyl halide. Next step is the transmetallation step, wherein the organometallic compound joins in. In transmetallation step, there is transfer of the alkyl group from the organometallic compound to the transition metal. Now, usually this transmetallation step happens by the transfer of alkyl group from more electropositive metal to less electropositive metal. So here the alkyl group is transferred from, so here an example we have taken zinc is transferred to palladium. Now this step usually is involved in most of the coupling reaction, isomerization. The final step is the reductive elimination, wherein the CC bond is formed between the two alkyl groups, and the palladium, which was in +2 oxidation state, is changed to 0 oxidation state. Okay, the catalyst is got back. Alright, and the new organic compound is formed via CC bond formation. So this is in general the mechanism of any type of coupling reaction: oxidative addition, transmetallation, reductive elimination. Now let us see Negishi coupling in detail. The Negishi coupling was discovered or was carried out in the year 1977. Okay, and the Negishi is a scientist, Ichi Negishi. Okay, he was part of the team who was working on palladium catalyzed cross couplings in organic synthesis. And Negishi got Nobel Prize. He shared Nobel Prize in the year 2010, along with Heck and Suzuki, Richard Heck and Akira Suzuki, for the same work. So the work was done in 1977. They got the Nobel Prize in 2010. Now, Negishi coupling involves the reaction between alkyl halides, usually aryl, vinyl, benzyl or allyl halide, with organo-zinc compound. The organometallic compound is organo-zinc compound in the presence of nickel or palladium catalyst. Okay, so Negishi coupling is reaction of alkyl halide with organo-zinc compound in the presence of nickel or palladium catalyst. And this reaction was first carried out for the preparation of unsymmetrical biaryls. They got good yield also for this reaction, unsymmetrical biaryls. So the two aryl groups will be different. So one aryl group will come from the organo-zinc compound, the other aryl group will come from the halides. The two aryl groups will be different. That's why it's called unsymmetrical compound. And such reactions are also called cross-coupling. When you couple unsymmetrical compounds, you call it as cross-coupling. When you get unsymmetrical compounds, you call it as cross-coupling. Now coming to the examples of Negishi coupling, you have here one example wherein the alkyl halide and zinc organo-zinc compound, in the presence of nickel catalyst, you get an compound, a hydrocarbon or another organic compound. So here either nickel or palladium is used as a catalyst. And the alkyl halide, alkyl part can be alkenyl, aryl, allyl, benzyl or propargyl. Similarly, organo-zinc compound, the organic moiety, can be alkenyl, aryl, alkynyl, alkyl, benzyl or allyl. So you mix these two, you get unsymmetrical compound. If you're taking alkenyl group, add two aryl groups of similar to aryl groups, then you get symmetrical compound. Now, as an example, you have here, I have taken two examples. An organic zinc compound, aryl iodide, you get a higher order organic compound wherein the aryl group is attached to this. Okay, similarly, another example. So these are general examples which you can use, aryl, alkyl, etc. Now let us see how the catalytic loop of Negishi coupling looks like, or let us go for the mechanism of Negishi coupling. Now, in this catalytic loop, the mechanism, you can find here the palladium catalyst, the transition metal catalyst. Here you have the alkyl halide, which comes together via oxidative addition, and the alkyl group and the halogen group are attached to the palladium now. So, in effect, it is like the palladium catalyst or the transition metal catalyst is inserted into the alkyl halide, between the alkyl group and the halide group of the alkyl halide. And during this step, what happens? The palladium, which is in zero oxidation state, is changed to palladium in +2 oxidation state. In the next step, in the transmetallation step, the alkyl group attached to the zinc is transferred to the palladium. So the alkyl group is transferred from more electropositive metal to less electropositive metal. So during transmetallation, the alkyl group of the organo-zinc compound is attached to the or transferred to the palladium. And then during the isomerization step, there is a rearrangement. The alkyl groups and the ligands are rearranged on the palladium, and then it is followed by the reductive elimination, wherein CC bond is formed. The two alkyl fragments come together, and palladium is the palladium catalyst is regenerated. Palladium from +2 is converted to palladium 0 oxidation state. The catalyst is regenerated. So this is the catalytic loop for Negishi coupling. Now coming to the applications, what are the applications of Negishi coupling? Now, Negishi coupling is mainly used in natural product synthesis. in natural product chemistry. It finds less use in industrial chemistry because the organozinc compound is sensitive to moisture and air. Now that's a disadvantage of Negishi coupling, the sensitivity of organozinc compound to moisture and air. But this disadvantage is overcome by the advantage that the organozinc compound is highly reactive and environment friendly, less toxic. So this finds use mainly in natural product chemistry. Let us take up a few examples of the reaction synthetic applications. Now, one application of Negishi coupling is in the synthesis of stemoamide. Stemoamide is an alkaloid obtained from Stemona tuberosa. It is obtained from the roots of Stemona tuberosa, and this extract is used for the treatment of respiratory diseases in Chinese and Japanese folk medicine. So stemoamide can be synthesized by Negishi coupling. You can find here organozinc compound, okay, and this is the organic halide compound. You have the halogen part here. Okay, the sort of ring closure happens. Yeah, stemoamide is formed. The fragments are added here. Where is it? Iodide and zinc. Okay, now another example is the synthesis of gamma trans tocotrienoleic acid. Gamma trans tocotrienoleic acid. Now, this particular compound is inhibits DNA polymerase beta. Gamma trans tocotrienoleic acid inhibits DNA polymerase beta, which is found during DNA repair. Okay, this particular compound is used in conjunction with chemotherapeutic drugs. Okay, so when you use this along with your chemotherapeutic drug, the dosage of the chemotherapeutic drug can be reduced, because this also helps in DNA repair, or inhibits the enzyme for DNA repair, and thereby the cancer cells, growth of cancer cell or multiplication of cancer cell can be stopped using. I mean, the dosage for the dosage of the chemotherapeutic drug can be reduced. So the side effects because of the chemotherapeutic drug can also be reduced. So these two synthetic applications you just remember: synthesis of stemoamide for which is used for in Chinese folk and Japanese folk medicine, and synthesis of gamma trans tocotrienoleic acid. Okay, so this is in general about the synthetic applications of Negishi coupling. So if you have any clarifications regarding this, please feel free to ask. All right, thank you.